Welcome back everyone, and we're on to question 4 of May, June 2025, paper 43, chemistry. This question is about sulfur. Sulfuric acid is manufactured in 4 processes. So the first stage, sulfur dioxide, is produced from ores containing sulfur. Stage 2, sulfur dioxide reacts with oxygen to form sulfur trioxide. Stage 3, sulfur trioxide reacts with concentrated sulfuric acid to form Oleum, and they've given us the formula here, which is great. And stage 4, Oleum reacts with water to form concentrated sulfuric acid. What we've got to remember for this question, and a good one for a flashcard, is what sulfuric acid is. This is sulfuric acid. Okay, H2 SO4. That's what we've got to remember. This SO4 is always a sulfate. Another good one. And of course, it's an acid, so it has hydrogen. And hydrogen has a charge of +1. SO4 or sulfate has a charge of -2. So to balance this out, we need 2 of the hydrogens to balance out the 2 minus of the sulfate ion. For the first question, we have to balance this equation. The ore contains a compound with a formula Fe2, reacts with oxygen in the air to produce sulfur dioxide. So this is the roasting process. How do we balance this equation? So they've already given us the number of moles is for the iron pyrite. So they've told us that it's 4. So that means the iron and the sulfur, the number of molecules, the number of moles has already been determined for us, because on the right hand side the only other reactant is oxygen. Okay, so that's going to help us a lot. So we've got 4 ions and we have 4 times 2, which is 8 sulfurs. Okay, so that means we've got to make 4 ions on the right hand side. This ion already has a 2. So what do we have to times 2 by to make 4? That means we're going to have a 2 in the front. Easy peasy. Okay, and then the next one, which we've just talked about, is sulfur, and we have 8 on the left hand side, which means we need to make 8 on the right hand side. The sulfur in the sulfur dioxide does not have a little number, so that means we're just going to write 8, because technically there's a secret little 1 here. So we've got that. Now we've just got to work out how many oxygens are on the right hand side. So we've got 8 times 2 plus 2 times 3. 8 times 2 is 16. 2 times 3 is 6. Just got to add those 2 together. If you are ever unsure about your answer and you struggle with mental math, whack it in the calculator. So this is going to give us 22 oxygens, which means we need to have 22 oxygens on the left hand side as well. How do we do that? We've got 2 oxygens here. What do we have to times by 2 to make 22? Or what we would do to work this out on the calculator, we would just move the 2 onto the other side by dividing. So 22 divided by 2, which is 11, completing our equation here. Any doubts, please let me know in the comments. On to the next one, complete the dot and cross diagram in figure 4.1 to show the electronic configuration of an oxygen molecule. So the easiest way to work this out, if you have no idea in the exam, is to go to your periodic table. It's going to be your lifeline. So let's look at oxygen. So oxygen is in group 6, which means it has 6 electrons in its outer shell. 1, 2, 3, 4, 5, 6. Amazing. So we know each one has 6, which means it's missing 2 electrons in its outer shell, because we can fit 8 in total, and having 8 in the second shell, third shell, etc. is the most stable. So that's what these oxygen atoms are going to want to do. So they're going to share their electrons. This too tells us how many electrons of each of the atoms are going to be shared. So there's going to be 2 from one of them and 2 from the other one. We need to do dots for one and crosses for the other oxygen atom. The next step that we have to do is we already know how many electrons there are in the shell. That we can't gain more electrons from nowhere. So for example, we've already got 1, 2 from this atom, 3, 4, 5, 6. We can only have 6 per oxygen atom. And then on the other one we've got 1, 2, 3, 4, 5, 6. So now we have in each of the rings, if we want to double check that there is 8, 1, 2, 3, 4, 5, 6, 7, 8. Yep, so we've checked that off. And in the left hand side, 1, 2, 3, 4, 5, 6, 7, 8 in the shell. That doesn't necessarily mean 8 from one of the oxygens. If it already had 8, I notice a lot of students, they work out how many are in, or how many are shared, and then they go ahead and then add, make sure that they have 8. So that's 1, 2, 3, 4, 5, 6, 7, 8. But we didn't have 8 from this oxygen. We didn't have 8 electrons originally. We couldn't have got these 2 extra electrons from nowhere. Okay, but any doubts about that, please let me know in the comments. So we've got B part I. State 3 typical conditions for the reaction between sulfur dioxide and oxygen in stage 2. What is stage 2? That is the contact process. We need to know the 3 conditions of the contact process. This is another great one for a flashcard, and you're going to hear me say that often. Okay, but 3 easy things that you can remember for the exam, 3 extra marks. Sometimes it gets confusing with the Haber process. I get that. Try to differentiate them. So the contact process to make sulfur dioxide reacts with oxygen to form sulfur trioxide. So sulfur dioxide plus oxygen, and this is the reversible reaction part, which makes sulfur trioxide. This is said in the question right at the top. Okay, so this is actually the equation. It is reversible. It is not balanced though, unfortunately, but we'll worry about that in the next question. It will come up. Okay, so the 3 conditions. It is 450 degrees C because the forward reaction is exothermic, which means heat is released when this is made. Heat is released. So that means it's going to get hotter and hotter, but that's then going to favour the backwards reaction. Okay, so it's going to be heating and heating, but the backwards reaction, if the forward reaction is exothermic, the backwards one is endothermic, taking energy from the outside. And if there's lots of energy on the outside, lots of heat, it's going to want to favour the backwards reaction, which means we ideally would like a low temperature. But if we have low temperatures, that means low rate of reaction. So this is a compromise, and that's something that they like to ask questions about as well. Not as often as the conditions, but they do like to ask about it and relate it to other topics in not just the contact process. 450 degrees C. The next one is 2 atmospheres, and the third one is vanadium 5 or V oxide. And we have to write catalyst, because we're not just writing, there's this, what is it for? Be specific. Otherwise you don't get the 3rd mark if you don't write this here. Onto the next page. Write a symbol equation of the reaction that occurs in stage 2. We've just been talking about stage 2 and we've got it written here. So let's rewrite it. Sulfur dioxide plus oxygen gas, then needs oxygen, is diatomic. And they've given you that information in the previous question with this dot and cross diagram. They are trying to help you. They don't always try to help you, I get that, but they are telling you that there's 2 oxygens to get you through this 1 mark question. That's probably why this is only 1 mark. In theory, they're telling you the answer, and so they are only awarding 1 mark for this. So like we said, this is the reversible reaction, and we're making SO3 or sulfur trioxide. The sulfurs, they are balanced. The oxygens, they're not. On the right hand side we have 4, and we only have 3 on the right hand side. So something to recognise with balancing equations, look out for the odd numbers. Typically don't work unless there is an odd little number on both sides. So here we've got a 3, so we need to make that even, because we're not going to make an odd number with either of these twos. There's no chance. 2 times 2 or 2 plus 2 is never ever going to give you an odd number. So that means we're going to put an even number in front. So let's put 2 times 3 will be 6. How can we then balance what's on the left hand side? So we've got 2 sulfurs, for example, now. So we're going to have to put a 2 there. We've now got 4 oxygens from 2 times 2 plus 2 would be 6. So 2 times 2 is 4 plus 2 would equal 6. Now we are balanced. So whenever you come across a balancing equations question, start with the odd number. Make it even, then start balancing. Otherwise, you can sometimes end in a bit of a loop and you get stuck on all of the odd numbers. All right, write the symbol equation for the reaction in stage 3. The answer to this one is in the question. We have to look at the information on stage 3. Sulfur trioxide, so sulfur with 3 oxygens, so literally what we've just written, sulfur 3 oxygens. Alright, sulfur trioxide reacts with concentrated sulfuric acid. This is the only thing we need to know for this question, because they've also given us what is made coming out of the equation. So let's write that. What's coming out of the equation is Oleum H2 SO2. Okay, H2S2, make sure I've written that down right. Yeah, S2O7. And we've got to know, which we've already talked about, the sulfuric acid, H2SO4. Okay, so the symbol equation. And is it balanced? So we've got 2 hydrogens, 1 sulfur, 2 sulfurs, 3 oxygens, 4 oxygens, that would be 7 oxygens. Yes, it's balanced. Okay, on to oxidization numbers. Right, there's some rules that we've got to remember. Elements, their oxidization number is always 0, which is a nice easy one in the beginning. Give the oxidization number of carbon in. So we're just looking for the oxidization number of carbon in the first one. In carbon, and it's an element, it's on its own, it's not with anything else, it's not a compound. Easy marks, 0. Thankfully we don't have to put a plus or a minus, they are important in the other ones. What is the oxidization number of carbon again? In CO2. Okay, one thing, so we've got carbon and then the oxygen, and each of these oxygens has a charge of -2. So O, the ion, has a charge of 2-. Okay, let me just rub this out. But we have 2 of them. Let me just write this. Let's move this over here. So this is just 1 oxygen ion. So if we times this by 2, because there's 2 of them in carbon dioxide, this is going to be -4 overall. -2 times 2 equals -4. And in a compound, the oxidization numbers also have to balance each other out and make 0. So if we've got a -4, that means the carbon must be a +4. So we're going to write +4. On to everybody's favourite, part D, all about moles. So what we're going to need is the moles equation. If you prefer triangles, this is the triangle. Make sure you remember this. You will need to know it every year. 100% of the time a moles question comes up, if not multiple times. So number of moles is the mass on the top and the relative molecular mass, and we will either find this information on the periodic table or kindly they have given it to us, and that is made this question just 1 mark. So what are we trying to find? Calculate the number of moles of sodium hydrocarbonate in 4.2 grams of that sodium hydrogen carbonate. So we've got the mass is always in grams, and we've got the MR. All we have to do is plug it into the equation. So N equals M over MR. 4.2, 84. plug it into your calculator, and you should get 0.05 moles. On to the trickier part. Deduce the number of moles of carbon dioxide gas. So now we've got to look at the equation because they haven't given us the mass, so we can't use this equation. We've got to use the symbol equation. And we're going to look at the ratios between sodium hydrogen carbonate and the carbon dioxide. And what do I mean by that? I mean this number that's in front here, so 2, so let me just write that out. Carbon dioxide, 2. We can see both of them are 2, so this is a ratio of 1 to 1. That means whatever number of moles there are of sodium hydrogen carbonate, it's the same number of moles as that of carbon dioxide. Nice easy question. All that we're going to write down is the same again, 0.05 moles. The next question, we are going to need another equation, but you don't necessarily, because they always tell you 1 mole of any gas occupies 24,000 centimeters cubed or 24 decimeters cubed. They want the final answer in centimeters cubed, so we're going to use their value in centimeters cubed. So that means the volume per mole is 24,000 centimeters cubed. We've just formed an equation, the volume per mole, because they're not just saying this is the volume of gas for 1 mole, it's like for 2 moles would be double that, or for half it would be half of this. That's what they're trying to tell you by this information. Like, for example, if I said I have 1 kilo of flour, that equals 10 cakes. If I wanted to make 20 cakes, how much flour would I need? I would need double. Okay, so volume per unit mole is 24,000 centimeters cubed, or 24 decimeters cubed if we wanted our final answer in decimeters cubed. Then how are we going to find the volume? All we have to do is move decimals onto the other side. If you do prefer memorizing the equation rather than trying to figure out it in the exam and maybe making a mistake, the number of moles is equal to V over 24,000 or 24 decimeters cubed. You choose which one you need to use depending on the units they want from you. So if we want the volume, we're going to cover that up. Then we're doing number of moles times by 24,000. And the number of moles we've already worked out, which was 0.05 times by 24,000. We're going to plug that in the calculator and we should get 1,200 or 1,200. Is that what you got?